Hi guys, welcome to my channel. This is Grishma MS, currently studying in Sri Venkateswara College of Engineering. Today is my subject about data structure and applications. So the topic is about pointers. Introduction to pointers. Pointers are variables that store memory addresses. They allow us to indirect access and manipulate data in memory. Pointers are fundamental concepts in programming languages like C and C++. Declaring and initialization of pointers. Pointers are declared by using an asterisk before the variable name. They must be initialized with a memory address of another variable. As we can see in the image that how the declaration and initialization of a pointers are taken place. Dereferencing pointers. Dereferencing a pointer means accessing the value stored in the memory address it points to. It is done by using an asterisk operator before the pointer's variable. Null pointers. So null pointer does not point to any valid memory addresses. They are initialized with a special value called null. They are often used to indicate that a pointer does not currently point to anything. So a null pointer is a pointer that does not point to any memory location. It represents a invalid memory locations. When a null value is assigned to a pointer, then the pointer is considered as null pointer. The example as we can see in the image, int main and int print is equal to null. So this is a null pointer and return 0. Pointer arithmetic. Pointer arithmetic allows us to perform an arithmetic operations on pointers. Adding an integer value to a pointer moves it by that many elements. Example, print plus 2 moves to the pointer 2 elements forward. Array pointers. Arrays can be accessed using pointers. The name of an array is a pointer to its first element. Example, int array in the bracket 5. Pointers to pointers. Pointers can also point to other pointers. These are called pointers to pointers or double pointers. They are useful in certain advanced programming scenarios. Dynamic memory allocation. Pointers are used to allocate and deallocate memory dynamically. The functions malloc and free are commonly used for this purpose. Dynamic memory allocation allows us to allocate memory at runtime. Memory allocation functions malloc, calloc, free, reloc, malloc allocates requested number of bytes and returns a pointer to the first byte of the allocated space. Calloc allocates space for an array of elements, initialize them to 0 and then returns a pointer to the memory. Free frees a previously allocated spaces. Reloc modifies the size of a previous allocated space. Passing pointers to function. Pointers can be passed to functions as arguments. This allows the function to modify the original variables. It is an efficient way to pass large data structure. Pointers and structure. Pointers can be used to access member of a structure. They allow us to avoid making copies of the entire structure. Pointers to structure are widely used in programming. Pointers and linked list. Linked lists are data structure that rely heavily on pointers. Each node in linked list contains a pointer to the next nodes. Pointers make it easy to insert, delete, and travels linked list. Linked list data structures. A linked list is formed from many nodes linked through the next pointer. The last element will have the next property pointing at null. The first node has the head node. Pointers and dynamic data structure. Pointers are crucially in implementing dynamic data structure like trees and graphs. They allow us to create complex data structures that can uh, grow as needed. Pointers enable efficient memory management in these structures. Common mistakes with pointers. Dereferencing uninitialized or null pointers can lead to crashes or undefined behavior. Memory leaks can occur if dynamically allocated memory is not proper fed. Incorrect pointers arithmetic can result in accessing invalid memory addresses. Pointer safety and best practices. Always initialize pointers before using them. Check for null pointers before dereferencing them. Free dynamic allocated memory when it is no longer needed. Benefits of pointers. Pointers provide a way to efficiently manipulate the access data in memory. They enable dynamic memory allocation and deallocation. Pointers facilitate the implementation of complex data structure and algorithms. Advantages of pointers. Pointers are useful for accessing memory allocation. Pointers provide an efficient way for accessing the elements of an array structure. Pointers are used for dynamic memory allocation as well as deallocation. Pointers are used to form complex data structure such as linked list, graph, tree, etc. The conclusion of the pointers are powerful concept in programming language. They allow for efficient memory management and data manipulation. Understanding pointer is crucial for low-level programming and advanced data structure. Thank you for watching my video. I hope that you like this video. Please like, share and subscribe.